Once again, I welcome back DLF online class. So now we are going to see number based conversion. This is the continuation class. So in the previous video, uh, I just explained the four types of number system: binary, decimal, octal, and hexadecimals, and what are the basis of these four number systems. Now the number based conversions. There are four number system. One is decimal, the base is 10. Then binary, the base is 2. Octal, the base is 8. Hexadecimal, the base is 16. First, the conversion is done on binary to decimal or decimal to binary. Okay, its equivalent magnitude. That is binary to decimal. Then the base 10 to base 2 or base 2 to base 10. The next one is octal to decimal. Then decimal to octal. Okay, octal to decimal and then decimal to octal, which is base 10 to base 8 or base 8 to base 10. Then third one, base 10 to base 16, base 16 to base 10. Likewise, octal to binary, binary to octal, octal to hexa, hexa to octal. So these are all the conversion we have to done in the next slides. Okay, first, decimal to binary conversion, that is the integer to binary conversion, or base 10 to base 2. First, it divide the number by base. What is uh, the binary is base 2, which is divided by the integer. The first step, divide the number by base 2. Suppose we take one integer number 13, which is divided by 2. Okay, so that is the meaning of first point. Next, here you see that 13 divided by 2, that means 6 2s are 12. Then take the remainder either 0 or 1 as a coefficient. Okay, if the remainder is take, that is 30, 6 2s are 12, but I divide by 13, so you get remainder is 1. So the remainder is take coefficient for 1. After that, you take the coefficient, again you divide by base 2. This method is called double method. So 6 divided by 2, 3 2s are 6. Now the remainder is 0. That is the second coefficient of that number, that is a1. After that, take the coefficient for divided by 2, again the base 2. The quotient, that is the remainder is 1. Now the remainder is take on coefficient of third for that number. Now 1 divided by 2, it is 0. Now the remainder is 1. Finally, you take the coefficient bottom to top. So we get the answer for its equivalent, that is base 10, which is equivalent to binary is 1101. So which is the decimal to binary conversion. Okay, so there are three steps of that. First, you divide the base 2. Take the remainder either 0 or 1 as a coefficient. After that, the quotient will be take and repeatedly divided by base 2 until it reach 0. Okay, that is the condition. So this is for first conversion for only a integer part. So these are all some examples for the another method. Suppose we divided by 25, which is a base 10 for converting binary. So 25 divided by 2, you take quotient is 12, remainder is 1. Now I can take the quotient, again take the quotient divided by 2, 6 2s are 12, remainder 0. Again you take quotient for 6, the 3. So 3 means 1 2s are 2, remainder 1. Now finally we get the remainder for 1. Now we can take bottom to top. So 11001, which is the binary of equivalent 25. That is the decimal. Okay, so this is called decimal to binary conversions. There are three methods are there. First method, then other method. The above process may be simplified as under successive divisions. This is also uh, for the converting decimal to binary, but the only condition is you take remainder is bottom to top. That is very important for. So this is decimal fraction to binary conversion. Before the decimal integer to binary conversion, you divide the number by base 2. Now multiply the number by base 2. Okay, now one example 0.625. There are two parts. From the left hand side it is an integer part, from the right hand side 0.625 is a fractional part, which is indicating base 10 decimal number. So now take the decimal number, that is a fractional part, for multiply the number base 2. There are two portions are there after multiplying integer and fractional part. The integer part is directly take coefficient. Take the integer part as a coefficient. So it is a power minus 1 equal to 1. After that, the fractional part will take again you multiply by base 2. Now the integer part is 0, then fraction part is 5. The integer part goes to coefficient. Then the 5 again multiplied by 2. So now the integer part is 1, then fractional part is 0. You take integer part is the coefficient 3. Now the fraction part is 0. Until the fraction part is reach 0, you stop the multiply by 2. Now the answer is take top to bottom. Before that, in the fraction integer part, that is the decimal integer to binary conversion, the coefficient will be take bottom to top. Here in fractional part, the coefficient is will take on top to bottom. Okay, so these are all the two methods for integer and fractional. Integer method is divided by 2 until the remainder is reach 0. From the fractional part, you multiply by 2 until the fractional part will reach 0. Okay, so these are all the two methods for converting decimal to binary, and one is integer, another one is a fractional. So this is the table for binary equivalent decimal number. So there are 30 decimal numbers and its equivalent 30 binary numbers are there. The first decimal one is 1, 2 for 10, not it is 10, so you call it as 10, 3 for 11, 4 for 100, likewise 18 for 10010, or 28 for 11100. So this is the binary equivalent decimal numbers. Okay, so there are 30 binary numbers are there, then 30 decimal numbers are there. So you can uh, draw in the table. Next, decimal to octal conversion. What is the 175 is a decimal number because it is 10. Now it is convert base 8. Before that, base 2 is decimal to binary and decimal fraction to binary. These are all the conversion already done in the previous slides. Now the decimal to octal conversion. First you take 175 is divided by 8. Divided by 8. Now the quotient is 21. Then the remainder is 7. The quotient directly take onto first coefficient. After that, the quotient is divided by 8. That is 2 8s are 16. The remainder is 5. So the remainder will take on coefficient. Now the coefficient is divided by 8, it is 0. So finally the answer is 175 is, which is equivalent octal is 257. So you take bottom to top for the coefficient, you get the answer 257. That is decimal to octal conversion. For that fractional part, we take fractional part 0.3125. For multiply by 8, multiply by base, okay, number which is multiplied by its base, that is 8. So which is multiplying, you get 2.5. There are two parts, one is integer part, another integer part directly taken to coefficient. Then again 5 is multiplied by 8, so 40, that is 4.0, integer will take coefficient. So easily you convert 0.24 is a octal of 0.3125 is a, it is decimal. Okay, so this is called decimal to octal conversion for integer and a fractional part. Okay, we will see in the next class for other conversions. So keep on watching. Any doubt, if you contact me. Thank you.